Hi everyone, thanks for joining me once again, where today we're going to have a little look at a meta-analysis, a meta-regression. This is a paper put together by Lauren E. O'Connor and colleagues from various different places, various different institutes around the world. And their paper is entitled Effects of Total Red Meat Intake on Glycemic Control and Inflammatory Biomarkers, a meta-analysis of randomized controlled trials. Fantastic. So without too much further ado, we'll just need to explain a couple of those terms just for anyone who's a bit lost on those. Glycemic control just refers to the control of the level of sugar in your blood. And inflammatory biomarkers is a flash word for some tests that can be done which can establish that a given person is experiencing an amount of inflammatory process in their body. Meta-analysis is just looking at a bunch of different research papers and combining the results of those papers together. So instead of having a number of small-scale studies, you have one larger-scale study which therefore has greater statistical power, greater predictive abilities when you extrapolate the results out to the appropriate population of people to whom it should be extrapolated. And randomized control trials are just studies where participants are randomized into one condition or another. In this case, it's a dietary intervention, that being how much red meat is consumed. And then they look at the results in terms of the blood sugar control and the inflammatory biomarkers. So let's dive in. Awesome. Okay, always a good place to start when we are reading through a scientific paper is to look at the abstract, which is like an executive summary of the paper. It should give you a good idea of what was done, how it was done, and what they found. So let's see if this abstract meets those lofty goals, shall we? Here we go. Our objective was to conduct a systematic review and meta-analysis to assess the effects of total red meat intake on glycemic control and inflammatory biomarkers using randomized controlled trials of individuals free from cardiometabolic disease. Okay, good. We hypothesized that higher total red meat intake would negatively influence glycemic control and inflammation based on positive correlations between total red meat and diabetes. We found 24 eligible articles with a median duration of 8 weeks from 1,172 articles searched in PubMed, Cochrane, and Chenal up to August 2019. That included 1. Diet periods differing in total red meat. 2. Participants aged equal to or more than 19 years. And 3. Included either men or women who were not pregnant or lactating. 4. No diagnosed cardiometabolic disease. And 5. Data on fasting glucose, insulin, HOMA-IR, which is a gauge of insulin resistance, which has become the gold standard test for that. A glycated hemoglobin, which just means red blood cells which have experienced a high degree of exposure to sugar. C-reactive protein, which is a marker of systemic inflammation. Or cytokines, which you will also find present in those who are inflamed. Okay, good. We used 1, a repeated measures ANOVA, analysis of variance that is, to assess pre to post diet period changes. 2, random effects meta-analyses to compare pre to post changes between diet periods with equal to or less than versus more than 0.5 servings, which is defined as 35 grams per day, of total red meat. And 3, meta-regressions for dose-response relationships, which is just a way of saying we correlated X with Y. Okay. We grouped diet periods to explore heterogeneity sources, meaning what caused the differences between the outcome statistics reported by different papers. Why were they different? Including risk of bias, using the National Heart, Lung and Blood Institute Quality Assessment of Controlled Interventions Studies. Okay. Glucose, insulin, and insulin resistance values decreased, while glycated hemoglobin and C-reactive protein values did not change during total red meat or alternative diet periods. There was no difference in change values between diet periods with equal to or less than versus more than 0.5 servings per day of total red meat. Weighted mean differences, 95% confidence intervals, were glucose 0.04 millimoles per litre with a 95% confidence interval of negative 0.049 to 0.129, insulin negative 0.710 picomoles per litre with a range of minus 6.582 to 5.162. The HOMA-IR scores were average 0.110, 95% range 0.072 up to 0.293. C-reactive protein 2.424 nanomoles per litre with a range minus 1.460 to 6.309. And no dose relationships. P is greater than 0.2. Okay. Risk of bias, 85% of studies were fair to good, were rated as fair to good, is what that means. And so these authors conclude that bias did not influence these results. Okay. Total red meat consumption for up to 16 weeks does not affect changes in biomarkers of glycemic control or inflammation for adults free of, but at risk for, cardiometabolic disease. Okay, so there you go. Basically what they said is they had a look at the studies which looked at markers of blood sugar control and inflammation with respect to whether they ate basically no red meat or a little bit or more than a little bit. So the only two categories there are greater than or equal to half a serving per day or less than half a serving per day. So interesting. We're comparing basically no meat with any amount at all, with an arbitrary cutoff of half a serving being defined as above there. Okay, and what they found was that there were no differences between populations for the consumption of red meat in terms of either the control of blood sugar or indeed inflammatory markers for at least 16 weeks of intake. Obviously, I would personally like to see a longer intake than just 16 weeks for a long-term assertion to be made. However, interesting. Okay. Let's have a quick look at the introduction. Type 2 diabetes mellitus and non-congenital cardiovascular diseases, often collectively referred to as cardiometabolic disease, are comorbid conditions that share behavioral risk factors. Okay, so those two disease processes have been associated with dietary factors, and the dietary factors associated with both those diseases are similar. Fine. A popular hypothesis is that the combined category of red and processed meat intake is a risk factor for cardiometabolic disease development. Okay. When unprocessed meat is assessed independently of processed meats in meta-analyses, unprocessed red meat neither increases risks of developing or dying from cardiovascular disease, nor negatively influences cardiovascular disease risk factors. So there you go, red meat exonerated that is not processed. But processed red meat may still impose risks. Again, we shouldn't be using the word risk here. Meta-analyses of these kind, epidemiological studies of this kind, are completely unable to inform on risk. They are not metabolic lock-in ward studies conducted on human beings over significant numbers of years, because obviously you can't do that. So we're talking about associations here and not risks. That said, however, associations between red meat types and cardiovascular disease are more consistent than associations between red meat subtypes and type 2 diabetes mellitus risk. And there is limited compilation of randomized controlled trials assessing effects of red meat subtypes on clinical biomarkers associated with type 2 diabetes mellitus. An investigation of how red meat intake influences risk factors associated with type 2 diabetes mellitus is needed to complement the aforementioned research on cardiovascular disease risk factors. This will further our understandings of the influence of red meat intake on the comorbid conditions of cardiometabolic disease as a whole. No, associations, not influence on. That infers cause and effect, which you cannot establish using associative studies. Okay. There are several proposed mechanisms as to why the combined category of red and processed meat intake may increase cardiometabolic disease risks in longitudinal observational studies. So watching people for long periods of time without cause and effect, without intervention, just associative studies. All right. The high sodium and nitrate contents of processed red meats likely explain the positive association with cardiovascular risk, and why associations between unprocessed red meat and cardiovascular disease are largely null. So basically these authors are pointing the finger of blame at sodium. They provide one reference in support of that, and in fact there is no evidence to support that sodium is the agent involved on a causal level. So that's a speculation. Anyway, beside the point to this paper really. Specific to type 2 diabetes mellitus, observational studies link elevated serum ferritin, advanced glycation end products, trimethylamine N oxide, and meat-derived zinc and heme iron to higher insulin resistance and metabolic syndrome in humans. Okay, so I have personally previously covered the TMAO argument on another YouTube channel that I run. I will remake that video in a format appropriate to this channel, and I will post that video in the days to come. In short, the TMAO argument does not work. It is nonsense. It is a reductionist idea that when you look at what actually goes on, you find that the TMAO problem is only theoretical and not actual. The same really applies to zinc and iron derived from meat. I mean, for goodness sake, we've been eating red meat as a species for 350,000 years, and for 2.5 million years before that in previous speciations. So it's not likely to be something that's likely to cause us a problem. These are speculations. These are guesses at mechanisms. Anyway, there we go. Potential pro-inflammatory characteristics of red meat, potentially leading to chronic inflammation, may be a ubiquitous risk factor for cardiometabolic disease risk more broadly. So maybe, possibly, could be, one reference that says maybe, possibly, could be. Not good enough. Not science. Anyway, let's move on. However, a few of these proposed mechanisms have been investigated or confirmed in randomized controlled trials. Good. The objectives of this meta-analysis and meta-regression were to assess the effects of consuming different amounts and different types of red meat on fasting biomarkers of glycemic control, the primary objective, and inflammation, the secondary objective, in adults with no history of cardiometabolic disease. Based on conclusions from observational studies linking higher red meat intake to an increased risk of diabetes, we hypothesized that greater total red meat intake would negatively impact the changes in glycemic control and inflammation, which are clinical biomarkers associated with type 2 diabetes mellitus risk. This meta-analysis was designed to complement previously published meta-analyses that assessed the effects of total red meat intake on changes in blood lipids, lipoproteins, and blood pressures, and to expand the understanding of how total red meat affects comorbid cardiometabolic disease risk factors. So, a lot to get our heads around there in the introduction. A lot of speculation, a lot of saying this is the reason why we hypothesize that folks who consume any amount of red meat will show a reduction in their blood sugar control capacity. They will show an increase in their systemic inflammation. That's what we're guessing. That's what these authors were guessing, hypothesizing. They gave a pretty weak, I think, background behind why they think that is so. They cited a very small amount of literature, none of which, if you actually go and look into the underpinning literature, is at all remotely convincing. Okay, so with that having been said, let's have a quick look at the methods section here. So they've registered the trial, they've registered their proposed procedures in advance. Great. They have indicated here that there's a particular search strategy that they have used. There it is. You can read through that in your own time. Fine. They've selected some studies on the basis of their arbitrary inclusion criteria, which is normal procedure. Doesn't, of course, mean it's right, but that's what's normally done. Fine. They have a little table in here which shows the process that they've gone through and how they've decided what studies are in and what studies are out and listed the studies. There they are. That's fine. Some search terms that they've used in their search strategy. Okay, all fine. They've defined some terms operationally. Perhaps a good idea. No problem. They've indicated what the basis is for their assessment of the potential for bias and why they don't think bias has played any particular role here. Fine. They've outlined their statistical methods and procedures that they have employed. No problems, really, to speak of. And then we finally get to the meat and potatoes, if you like, the actual results here. This is what's called a stem and leaf plot. This shows the studies that are included in the meta-analysis and the individual results of each of those studies, plus an indication of the particular weighting that that study has in the overall meta-analysis. The largest factor determining the weighting in any given meta-analysis is the sample size of the individual study. So smaller studies get less weight and larger studies more weight. And then at the bottom, we have an overall effect size indication there with 95% confidence intervals around it. So let's dive into that a little bit and just have a look at this table in a little bit of detail. This table is the effects of consuming equal to or greater than versus less than half a serving per day of total red meat on blood glucose concentration. Okay, so let's have a look at it, shall we? Okay, so starting at the top, we have O'Connor 2018. They found really no difference at all. We have Assertions 2007. We have Assertions 2007 again, a different cohort. Adland, Sayer, Liao, etc. down the page. And what we see here is how many of these individual meta-analyses found anything statistically different from 1. As an incidence rate, or what they usually call a risk rate. And if you look down, what we're looking for is studies where the tails of the error bars do not cross across the solid vertical line. And we see that Assertions 2007, AB, soy, nut 35 and 36 references, okay? We find that one is statistically significant, so the third one from the top. So that one isn't, no. That one is only just, so that's Hill 2005, WM, bold, plus 32. No, and no. And the overall result of the meta-analysis indicates that there is a very, very small difference, but the value crosses 1, and as such is not even statistically significant, let alone of any utility. So there we go. Nothing to show there in terms of the hypothesized idea, if you like, that the consumption of red meat would be associated with poorer control of blood glucose. We are now required as scientists, on the basis of this meta-analysis, to reject that hypothesis and accept the alternate hypothesis, which is that there is no difference between meat-eating populations and non-meat-eating populations in terms of their blood glucose control. All right, let's move on to the next result. All right, here we have the effects of consuming greater than or equal to versus less than half a serving per day of total red meat for blood insulin concentration. All right, so let's look for studies that cross the level of 1. No, yes, there's one there. Third one down, Navis Carretero, 2009. No, yes. However, it's the other direction from the other one. No. And the overall result there, absolutely not. It sits basically at 1. And so what we have there is nothing whatsoever. Okay, so with respect to the concentration of insulin, no effect there either. So not glucose and not insulin. Neither are negatively affected by a diet containing any amount of total red meat. Good. Let's move on to the next result, shall we? Okay, here we have the effect of consuming equal to or greater than versus less than half a serving of meat, total red meat per day on the HOMA-IR score, the gauge of insulin resistance, which has become gold standard in recent years. Alrighty. So looking for statistically significant results. 1, 2 there at the top, the second and third one down. Those are the only ones. However, when we take all the data into account, we get a result which once again crosses that critical value 1 and as such is not statistically significant, let alone of any utility. So no, HOMA-IR, insulin resistance, not negatively affected by consuming more than half a serving of red meat versus no red meat at all. Okay, what's next? Right, effects of consuming equal to or greater than half a serving of meat versus less than half a serving of meat for C-reactive protein, the marker of systemic inflammation. Not significant at the first one, second, third, fourth, fifth one, no, sixth, no, seventh, no, none of those are statistically significant except possibly the last one, and the overall effect is not statistically significant because it crosses 1. So there we go on that one. So the answer in terms of C-reactive protein, the marker of systemic inflammation, no difference between meat eaters and non-meat eaters, or those that eat more than half a serving versus those that eat less than half a serving. No. All right. What's next? Here we have a couple of interesting sort of scatter plots that show the size of the figure shows the sample size of the study concerned. The trend line shows what the trend is across the range of studies, and basically what the level of correlation is. In all cases, you can see the data is spread quite widely. The level of association is not great. The p-values here, some of them are quite high, like p equals 0.893 for the top left-hand chart there. However, you can see how widely spread the data is. I think that p-value is disingenuous. It doesn't give you the information to really gauge the veracity of these results. I think largely what we're seeing here is not very much of anything. However, if anything, the trend lines do suggest that the consumption of red meat versus not has basically no effect at all on blood glucose concentration. That's the top left hand. The top right hand says that the consumption of meat shows that if anything, more meat leads to less or is associated with a lower concentration of insulin. Okay, although nothing convincing there. It's the downward slope of that line is very, very slight, and the data is widely dispersed, so I take it with a grain of salt. A bottom left hand, chart C there, we're looking at the insulin resistance, the HOMA-IR score. That quite clearly actually suggests that the people who eat the red meat have lower insulin resistance values than those who don't. Which, you could say, well, that's probably because the ones who eat less meat are probably eating more carbohydrates, which would lead to a higher HOMA-IR score across time, potentially. Although, as I say, not convincing. Data spread quite widely around the trend line. The p-value there is 0.235, so nothing to see there. And finally, in the bottom right hand, we are looking at the value of C-reactive protein versus the meat versus non-meat, and that's a fairly convincing downward slopey line. However, the p-value is only 0.528, so again, take it with a grain of salt. But it would suggest that if anything, the meat consumption is associated with a reduction in C-reactive protein rather than the inverse, which was hypothesized, actually. It says quite clearly that at least over 16 weeks, if anything, the trend seen in the studies looked at in this particular meta-analysis, it looked like meat was associated with less inflammation, not more. It looked like meat was associated with less insulin in the blood, not more. It looked like meat was associated with less insulin resistance, not more. And it looks like, if anything, there's a slight upward trend in the line suggesting that meat was actually associated with slightly better blood glucose control and not worse. So there we have it. I hope this has been an interesting look into an epidemiological meta-analysis here. This was a paper that set out with the goal to prove that eating meat was bad, and it looks like they've failed completely to support the hypothesis. Very, very clearly here, what we have is no real result at all because there's no statistical significance in any of it. But if anything, the trend is towards meat being associated with better outcomes, at least in terms of blood glucose, insulin resistance, insulin concentration, and indeed C-reactive protein markers. So there you go. Join me next time when we'll have a look at some more scientific papers and see if we can tease out the meanings underpinning all of that. See you then.